Imagine boarding a plane, settling into your seat, and watching the world slowly disappear beneath the clouds. As you climb higher and higher, the ground turns into a distant blur. But have you ever stopped to wonder why planes cruise at around 35,000 feet? Why not lower? Why not higher? The answer is a mix of physics, engineering, safety, and economics, and it's far more fascinating than you might think. Let's start with the basics. Earth's atmosphere gets thinner as you go up. At sea level, the air is dense and rich in oxygen. But for every 1,000 feet of altitude, the air pressure drops by roughly 3.5%. By the time a plane reaches 35,000 feet, the air is only about a quarter as dense as it is at sea level. That change affects everything, from how much lift the wings generate to how engines burn fuel. At lower altitudes, the dense air causes more drag. That means more resistance, and more resistance means higher fuel consumption. Planes would need to burn significantly more fuel to maintain speed and altitude. On the other hand, go too high, say above 45,000 feet, and the air becomes so thin that jet engines struggle to operate efficiently. They simply can't get enough oxygen to burn the fuel properly. So 35,000 feet is a sweet spot. It's high enough to reduce drag and save fuel, but not so high that engines lose performance. This altitude also places planes above most weather systems, storms, and turbulence, which are concentrated in the lower layers of the atmosphere, especially below 30,000 feet. Flying at 35,000 feet also offers major safety advantages. If a plane loses engine power, it can glide for a surprisingly long distance. A commercial airliner at that altitude can glide about 100 miles depending on conditions. That gives pilots precious time and options to find a safe place to land. At lower altitudes, they'd have far fewer choices and much less time to react. There's also the issue of turbulence. At lower altitudes, planes are more likely to fly through weather systems, thermal currents, and unstable air pockets. At cruising altitude, the ride is generally smoother. While turbulence can still happen at 35,000 feet, it's usually mild and easier to manage. Fuel efficiency is another huge factor. Jet engines perform better at high altitudes where the air is cold and thin. The lower temperatures improve combustion efficiency, and the reduced drag allows planes to maintain speed with less thrust. That means lower fuel burn per mile traveled, which directly translates to lower operating costs and fewer emissions. Air traffic control also plays a role. The skies are divided into flight levels, measured in hundreds of feet, to help keep aircraft separated and organized. Eastbound flights typically use even-numbered flight levels, while westbound flights use odd numbers. These standardized cruising altitudes make global air traffic predictable and safe, and 35,000 feet happens to be one of the most commonly assigned flight levels for long-distance travel. Now, what about flying higher? Some aircraft do. For example, the Concorde cruised at 60,000 feet. Military planes like the U-2 spy plane have flown at altitudes over 70,000 feet. But those aircraft were built for extreme missions. Their designs came with major trade-offs, like higher fuel consumption, increased structural stress, and the need for special pressurization systems, or even pressure suits for the crew. On the flip side, flying lower, say around 10,000 or 15,000 feet, would expose planes to constant turbulence, changing weather, and higher drag. That would increase fuel burn dramatically and make the flight less comfortable for passengers. It would also place planes in the same airspace as helicopters, drones, and small private aircraft, raising the risk of mid-air collisions and complicating air traffic management. The decision to cruise at 35,000 feet isn't random. It's the result of decades of flight testing, scientific research, and operational experience. Engineers and pilots have learned exactly how planes behave at different altitudes, and 35,000 feet consistently comes out on top for efficiency, safety, and reliability. So the next time you're on a plane, glancing at the flight tracker on the screen in front of you, remember that there's a reason you're soaring 7 miles above the ground. Not because it looks cool, but because it's where everything works best. Lift, fuel, weather, safety, and speed. It's not just the cruising altitude, it's the optimal altitude. Subscribe us for more videos.